Alright, so we're going to look at another type of Sevian called the median, and the median is similarly drawn. We draw from we draw from the angle of a triangle to somewhere on the opposite side, except the median this time is that we draw specifically to the middle of the edge on the other side. So in the following diagram, as you can see on the screen, you can see that the line will basically bisect the edge, and as such these two shorter edges will be the same length, and that's going to be important in proving the theorem. Improving that all the medians of a triangle are concurrent. Now, just one last thing, that when you draw all three medians of a triangle, the middle point is called the centroid, and that along with the other way of drawing Sevians will actually have a relationship of which we'll see later. But as it is in the title now, I want to prove that the triangle medians are concurrent, and while it may seem reasonably easy to see in the diagram, it's also nice to kind of prove it in a formal sense. So now we call the way we're going to do this is that we're going to use the converse of Sever's theorem. So the converse of Sever's theorem states that if you satisfy the equation where each of the sides is equal to 1, where not each of the sides, each of the respective ratios, as if you remember Sever's theorem from the previous video, if you multiply those ratios together and you get equal to 1, then the Sevians are concurrent. So effectively, if you recall Sever's theorem with respect to the ratio, so you got A to D and D to B, and so effectively we've got a ratio there, A to D, D to B, and then because if you remember, that's how we do the ratio of the sides on the Sever's theorem, and then we got B to E, E to C, so that's B E, E C, and then the last one would be C to F, F to A. C to F, F to A. And the converse of Sever's theorem states that if we multiply all these together and we get equal to 1, then it proves that the three medians are concurrent. So in this case, as you may have realized already, that we know that AD is actually equal to DB. So it means that the relative ratio or the fraction will effectively equal to 1. So let me just jot this down a bit more formally. AD is equal to DB, and then so that effectively equals 1. And then you can see the same thing is happening for the other two sides. We can see that BE is equal to EC, so that's going to be equal to 1. BE is equal to EC. So and just to reiterate the point, they're equal because the nature of the median. The median connects to the middle point, to the midpoint of the other side, and since it's the midpoint, it means the two sides created by that midpoint will be equal in length. So that's going to be CF, and that's going to be equal to FA, and as a result, that's going to be 1. So therefore, we have 1 times 1 times 1, which is definitely equal to 1, and therefore we satisfy the converse of Sever's theorem in saying that if we multiply these ratios together and we get 1, then the medians in this case, the medians are therefore concurrent. So thankfully this is probably the only easy version. The next version with respect to the it's a different name which I don't quite remember, but the previous definitely a bit more convoluted. So until then.